today we're going to find the side length of a tilted square on a dot paper grid. We're going to do that today by dissecting the area of the tilted square, but we're also going to use right triangles to support our work. So let's go ahead and start. We're going to go ahead and draw a right triangle off the side of one of the side lengths of the square. We're going to go ahead and mark that there's the right angle because this leg and this leg of the right triangle intersect at the 90-degree angle. I want to share with you that these are the leg measurements, and then the hypotenuse, which is the longest side of the right triangle, is actually the side length of the tilted square. Pythagoras, who was a Greek mathematician, stated that if you squared the leg of both, if you squared both of the legs on a right triangle and added the areas together, you would get the square, or the measurement of the square, off the hypotenuse. So we're going to go ahead and do this today with this tilted square, and then we'll move to the one below. So first of all, we're going to measure the legs, or the side lengths of the right triangle. So if I go from this edge to this edge, this side length or this leg has a unit of 1 for a measurement. If I was going to draw a square off of that leg, I would want to make sure that each one of the side lengths are equal to 1 unit, and they are. And my area would be 1 unit squared, base times height. I'm going to go ahead and do the same for our other leg. This leg has 2 units of measurement. So if I was going to go ahead and draw a square off of that leg, I would want to make sure each side length of the square has 2 units of measurement, just like this. I would go ahead and do base times height, or count the boxes inside to have 4 units squared. So Pythagoras said, if I take 1 squared, which is this side length of the leg, and if I add it to 2 squared, which is the side length of this leg squared, then it should equal the hypotenuse squared. We're going to go ahead and try it out. So 1 squared we know is 1, 2 squared we know is 4, and we should get the area of this tilted square to be 5. So let's check it out. So I'm going to go ahead and dissect the square using a strategy. So this would be 1 unit squared. I'm going to go ahead and break apart the rest. So if I break apart the square, I'm going to go ahead and use a highlighter. If I do know that this portion right here has an area of 2 and I cut it in half, then I know that this is 1 unit squared, and then so would the other 3. So I'm going to call this 1 unit, I will call this 2 total, 3, 4, and 5. And sure enough, that does equal my hypotenuse squared. I just want to make sure that you know that sometimes the legs and the hypotenuse use different variables. So Pythagoras said a squared plus b squared is equal to c squared. So the 2 legs of the right triangle squared, when I add them together, should equal the hypotenuse squared. And sure enough, it does. I just want to share with you, though, that we do not know the side length of the hypotenuse, but we can find out. So we're going to go ahead and solve from here. So if I know that the area is equal to 5, then I would want to undo the square by taking the square root. And so my side length of C, which is my hypotenuse, would be approximately 2.2 units. Let's go ahead and try the next one. So this is a larger tilted square. It would take a little bit more time to box off and identify the number of units inside, but we're going to do that today. We're going to first go ahead and do the Pythagorean Theorem to see if we can identify what this area is. So I'm going to pick 2 vertices on that tilted square. I'm going to draw my right triangle around the edge of that tilted square, making sure that the hypotenuse measurement is the side length of the tilted square. I'm going to count my measurements. I have 3 units of measurement here. I have 4 units of measurement here, and I'm going to try to identify what the measurement is of this hypotenuse, which is the side length of that square. I'm going to go ahead and build the squares off of each side length or leg. So if this leg had a measurement of 3 units, then I would want to make sure when I draw my square that each side length of that square was equal to 3 units. And if I would find the area, 3 squared, which would be 9 units squared. Then what I'm going to do is I'm going to add it to the square off the other leg. So if the leg has 4 units of measurement, each one of the side lengths of the square should also be 4 units. I would go ahead and do 4 squared, or 4 times 4, and I would get 16 units squared. So if I added 9 plus 16, I would get 25. So what I should get when I dissect this tilted square is 25 units. So I'm going to go ahead and break it apart. Oops. Okay, so I have 1 unit in the middle here. And I'm going to go ahead and talk to you about these other portions. So I'm going to go ahead and box this off using a strategy that I feel comfortable with. I know that this is a 3 by 4 square, so there should be 12 boxes inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I cut that in half, then that means this portion should be 6. So if that's 6 units, and I have another 6 units here, and another 6 units here, and another 6 units here, 4 groups of 6 is 24, plus that 1 is 25. I'm going to go ahead and set it equal to c squared, which would be our hypotenuse measurement, which is right here, one of the side lengths of that square. And now, in order to find this measurement, we're going to take the square root. So if I take the square root to undo that square, my side length here would be equal to 5, which is right here. So if I was going to double check, if I did want to double check this one, I could do 5 times 5 and guarantee that I would have 25 units of area inside. Just like this one, I would do 2.2 approximately, and it would give me about 5. We're going to use this strategy today to help us find the distance between 2 points. We're going to go ahead and start with this. So if I have a line segment like this on a blank piece of paper, I can definitely use a ruler to measure. This would not be a situation where I'd want to use the Pythagorean Theorem. I have no other units of measurement here. It's a blank slate. So I would want to use my ruler to determine that this would be 3 inches. If I have a scenario where I have 2 points on an ordered pair, let's say this one on the left, if I look at this one, even though this is not dot paper, the distance between one dot to the next, or the one intersection point of where the blue lines intersect, this right here would be 3 units because I can tell the distance by counting. But this right here is a diagonal line, and even though I don't have the tilted square, we're going to use that strategy today to help us find the distance between these 2 points. So what I'm going to do is I'm going to draw a right triangle around this. And think about this. It's almost like you're using slope. You're going to go up and over. So you're going to go up vertically and over horizontally to get to the other vertice on this line segment. So we're going to make that right triangle. Now, instead of drawing out the shapes of the squares, we're going to go ahead and just use the theorem here. So if this right triangle's leg has a unit of 1, the square that I would draw off of that would be 1 squared, or 1 times 1. Then what I'm going to do is I'm going to determine the measurement of this leg. 1, 2, 3, 4, 5, 6. What I would do is then draw that square off of that leg. I'm going to go ahead and just do it algebraically. I'm going to do 6 times 6, or 6 squared, which is 36. When I add those together, I would get 37. Now just remember, 37 would typically be the area of the square that comes off that hypotenuse, but if I wanted to find the measurement of this side length or this line segment, what I would want to do is now take the square root. So if I take the square root of both sides, I would get C, which is this measurement here, is approximately equal to about 6.1. We're going to go ahead and do one last one today, and we're going to do an example of how I could find a side length measurement of a right triangle. So if I had a right triangle that looks like this, one of the leg measurements happened to be 3, and one of the leg measurements happened to be 5. And I wanted to find out what the length was of the hypotenuse. Now again, I wouldn't be able to use a ruler specifically on the diagram unless I knew it was on a grid paper or it had units of measurement or if it was to scale. So in this scenario, what I'm going to do is the Pythagorean Theorem. I'm going to take the leg of this triangle, and sometimes even I'll draw almost a generic square that comes off if I want to visualize. So that would be 3 squared, which is 9 for that area. I would add it to the square of this leg, so 5 squared. So if I did that, 5 times 5, the area that would come off here would be 25. And when I add those two together, 25 and 9, I would end up getting 34. Now remember, 34 isn't the side length of the hypotenuse. Remember, what we need to do now is take the square root, because that's going to give us this side length measure. And once I take the square root of both sides, C is going to be approximately equal to about 5.8.